Okay, so our next topic is exponential growth and linear growth. So we'll be talking about exponential functions in this topic. Exponential functions are those functions that have some variable in the power. Okay, some variable in the power. Now, this is the standard form of an exponential function, y equals ab raised to power t. What that means is you can have some constant multiplying outside and then another constant and have some power over that. So for instance, you could have something like this, y equals 4 into 3 raised to power x. This is an exponential function. Now this number outside could be positive, it could be negative. The number inside could be positive or negative, anything. Okay, this is what it looks like. Now, we can think of it as something that increases or decreases by a constant factor over time. So for instance, if you have a number like this and it doubles every year or every month or every day, what would the next values look like? 3, 6, 12, 24, 48, 96. This is exponential growth, right? It's increasing by some factor. All right, this is exponential growth. So as compared to linear growth, which would be something like this, that you have 3, 6, 9, 12, 15. Values are changing by some constant. कौन था? So this is what exponential growth looks like, and this is what linear growth looks like, right? In exponential growth, you're multiplying by something to get the next value. In linear growth, you're just adding or subtracting something to get the next value, right? Now, if it's exponential, so there are two variations that you can see here. One is exponential growth and the other is exponential decay. So something can increase exponentially or decrease exponentially. Now for exponential growth, this number is normally greater than 1. Because what that would mean would be, if you have something like this, for instance, y equals 3 into 2 raised to the power x. If you have something like this, every next value is going to be multiplied by 2. So if you input x equal to 0, what does that give you? Y equal to 3. If you input x equal to 1, that gives you y equal to 3 into 2 raised to power 1, that's 6. If you input x equal to 2, that gives you y equals 12. So every next value is multiplied by 2. So the numbers become bigger like this. This is called exponential growth. But if this number is smaller than 1, what would happen in that case? If it was, for instance, 3 into 0.8 raised to the power x. What's going to happen now? Every next value will be smaller than the previous value because you're multiplying by 0.8 now. So x equals 0 gives you y equal to 3. When you input x equals 1, that gives you 3 times 0.8, which is 2.4. When you input x equal to 2, that gives you another value which is even smaller than this. This is called exponential decay. All right? So for exponential growth, this number has to be bigger than 1. It has to be greater than 1. Is that okay? All right. Now, how are we going to use this? In this case, there's another important thing that you need to remember. This number outside, this is the initial value. In exponential functions, this value is always the initial value. Initial value means when this variable is equal to 0, right? This is always the initial value. A lot of times, the variable on the other side is t, which represents time. So over time, something might be increasing or decreasing. When you put t equal to 0, what do you get from that? You get this number. So at time 0, you get this value, which is a. So that represents the initial value. Initial value means the value at time equals 0. Okay? So this is the standard form of an exponential function. Now let's look at some examples on how this is tested. So let's say you have this person who has a savings account and he earns 3% interest compounding annually. His initial deposit was 800. Which of the following expressions gives the value of the account in dollars after 10 years? Now, how do we think about this? He's earning 3% interest annually and it's being compounded. Compounded means if you started from 100 and the next year you have 103, the next increase is going to be on this value, 103, not on the initial value, right? So that means it's compounded. Now, which expressions would represent the value after 10 years? How do you think about this? What's the initial value? 800. You have to start from 800, right? That's the initial value. Now, is this supposed to be an exponential function? How do we know that? How do we know it's an exponential function? Because every year the amount is increasing by 3%. We did percentages last time. If you want to increase something by 3%, what do you multiply that number by? 100% plus 3%. That's 103%. That can be written as 1.03. If you want to increase something by 3%, that means you're multiplying by 1.03. Is that okay? 800 is the initial value. So every single time, every single year, what you want to do is you want to increase this value by 1.03. So that's your growth factor. Okay? This raised to power t that represents time, this is what the function is going to look like. Right? When you input t equal to 0, you get 800. When you input t equal to 1, you get 800 into 1.03. That increases this amount by 3%. Right? This is what the function should look like. Now, which expression gives us the value after 10 years? What can we do for that? Just input t equal to 10, and that gives you 800 into 1.03 raised to power 10. Which option is that? That's option D. 800 into 1.03 raised to power 10. Is that okay? Sorry? A or D में difference क्या? This is 1.30. That means 30% increase. This is 3% increase. Okay? तो वो confuse करने के लिए similar values तरह से लिखी हुई हैं. So the first one is 30%. The last one is 3%. Is that okay? So that's how an exponential function works. Let's take another example. In fact, you can generalize this, the concept that we just looked at. You've done this in O-levels as well, I think. Compounded interest, how do you calculate that? It used to be, so what was the notation that we used to use there? P was the principal amount, and then you used to say 1 plus R over 100 and then raised to power n, where n represented the number of years. You can represent that by t as well, where t represents time, right? That's what this shows as well. A is the principal amount. That's the value that you're starting from. And then you have 1 plus the rate in decimals, right? 3% means 0.03. Is that okay? That's the general formula that you can use for compounding. Now this is an example of an exponential function because you have t as the power here. So this is an exponential function, okay? Now for compounding interest, you can use this general formula, all right? Now, this is another type of question that you'll often see in exponential growth. You'll have some population that will be increasing or decreasing by a certain factor. So let's look at this. The population of this ant colony doubles every month. So it doubles every month. क्या मतलब? 2 से multiply हो जाती है every single month. If there were 500 of them on May 1st, which function represents the population t months after May 1st? Now it doubles every month. So what's the factor? The factor is 2. 2 se multiply ho raha hai, right? What's the initial value? 500. So the number outside should be 500. The factor has to be 2. So t months after May 1st, it's going to be 2 raised to power t. T equals 0 is going to give you the initial value. T equals 1 will give you 500 into 2, that's 1000, and so on. That's what the function should look like. A or D में क्या difference है? There's no difference, so that's a mistake. So I have made these slides using ChatGPT, from College Panda book. I made the slides using ChatGPT. And for some reason it keeps changing values. वो थोड़ी सी change करते रहते हैं. Book में ऐसे नहीं होएगा. So yeah, this is basically identical. So the correct answer is A. Now sometimes you will need to figure out how the exponential graph looks like as well. This is the general shape of an exponential function. If the number inside is a positive number greater than 1. So if this is the form y equals a into b raised to the power t, let's say, this is what the graph generally looks like when b is greater than 1. When it's exponential growth, this is the shape of the graph. This value here, can anyone tell me what this should be? The y-intercept of this graph? The initial value, which is a. This point always has to be a, right? Because when you input t equal to 0, this is the value that you get, and that's supposed to be this value a, the initial value, okay? And this is the shape of the graph. It looks like an exponential increase. Is that okay? Now, exponential decay, I told you about this earlier as well. Exponential decay is when this number b is less than 1. Okay? In that case, you have exponential decay. It's the opposite of growth in this case. The graph is going to look like this instead. Okay? The graph decreases. It's going down like this. This is the graph of exponential decay. You should be familiar with this as well. Okay? In this case as well, you can see this is the initial value, but then that value is decreasing like this. Is that all right? Okay? All right. Now, this is very important. The examples that we have seen until now, they were fairly straightforward. We were just using the standard function, and we could just think of it intuitively as well. But sometimes the situation is a bit more complex. So what happens is, let me actually show you this example first. I'll go back to that slide in a moment. Sometimes you have exponential functions that look like this instead. So in the power, you have t over 3. Instead of t or x, you have t over 3. Now, what does this mean? It says this function models the mass of a particle after t years. Okay, it models the mass of the particle after t years. Now, how do you interpret 1.05 raised to power t over 3? Now, if it was just 1.05 raised to power t, what would you understand from that? What happens every year in this case? If it was like this, what would this mean? 1.05 raised to power t. The mass increases by 5% every year, right? That's what it means. It increases by 5% every year if it was 1.05 raised to power t. But here we don't have t, we have t over 3. What does that mean now? So if you input t equal to 3, if you input t equal to 3 here, what would you get? You would get 400 into 1.05 raised to power 3 over 3 in the function that's given. So when you input t equal to 3, that is what gives you 400 into 1.05 raised to power 1. How do you understand that now? When you input t equal to 3, you are multiplying 400 by 1.05. So in this function, the value is increasing by 5% every 3 years. It's not increasing every year, it's increasing by 5% every 3 years. Is that okay? Because when you input t equal to 1 here, after 1 year, we would just be multiplying by 1.05 raised to power 1 over 3. That's not 5% increase, that's less than that. जब t की value 3 input करेंगे, उससे आपको मिलेगा 1.05 raised to power 3 over 3, which makes it 1.05. So the value is increasing by 5% after 3 years, after every 3 years. So this should be B here. Okay? It's increasing by 5% every 3 years. Does that make sense? Now we can generalize this. Whenever you have a function that looks like this, so now in the power, you have t over k. Okay? You could have a fraction like this or some multiple of t like this. What does this mean? Y, of course, represents the value after the increase. That's the output that you have. That's understandable. A is the initial value. That's still the initial value as before here. K is the time required for the value of y to change by a factor of b. So in the previous example that we just saw, it was y equals 400 into 1.05 raised to power t over 3. What do you have in place of k? 3. So 3 is the time required for the value to change by this factor. So you need 3 years for the value to change by 1.05, by a factor of 1.05. Is that okay? Now this is important. T and k must be in the same units. So if you're considering t in years, you also have to consider k in years. Okay? Unit same hona chahiye, otherwise we cannot divide them, right? Is that okay to everyone? No problems? Now I would highly recommend that you memorize this form. It's going to be very useful in a number of different questions on exponential growth. You should remember this form and remember what k represents. Okay? That's the time required for the value to increase by that amount. Make sense? Any problems?
So it's basically it will increase
it will increase after this much time has passed, whatever the value of k is. So now since the unit here for time is years, if this number is 3, we are saying it increases by 5% after 3 years. So k is the time required for the value to change by that factor. Is that okay? All right, let's look at another example. So now we have another very similar function. This is the mass of a particle after t years. Which of the following is the best interpretation of 0.6 raised to the power t over 3? How do you understand this? Yes, how many of you think it's A, B, C, D? Okay, so B or D? B, raise your hands again for B. D. Okay, so that's like 60-40 for B and D. So all of you understand it's supposed to be 3 years then, right? The change happens every 3 years because this number is 3. Now, how much is that change? When you're multiplying by 0.6, what does that mean? The initial value was 100%. That goes to 60%. What's the decrease? It's a decrease of 40%. Right? So the mass of the particle decreases by 40%. It decreases to 60%, but it decreases by 40%. Understand the difference? If the initial value is 100%, that changes to 60%, but the change is by 40%. Is that okay? 100% से 60% पे जा रहे हैं. That means 100% say the value is changing to 60%. लेकिन change हुआ कितना है? What's the difference? 100% से 60% पे जा रहे हैं. The change is by 40%. It has decreased by 40%. The difference is 40%. And that's what they're asking for. It's by here, right? So it decreases by 40%. Is that okay? No problems? All right, let's move on. This organization has 50 volunteers. If the organization doubles the number of volunteers every 8 months, which equation best models the number of volunteers after T months? Yeah, so they are both the same. I'll just cancel it out. Sorry. So A, B, or C? Which one is this? A? All of you agree to that? It should be A, right? So the change happens every 8 months. And it has to double, so the factor has to be 2. That's 2 in all of these cases. But then T over 8 means it doubles every 8 months, right? So it's A basically. All of you understand this? Right? So this form is really important. It will help you a lot. A, B raised to power T over K. G, Roma. K टाइम है तो K रिप्रेजेंट कर रहा है कि कितनी देर बाद आपका वो इंक्रीज होता है. T एक सिंगल यूनिट है टाइम का. सो फॉर एग्जाम्पल चल इसे इधर ही देख लेते हैं. T is the variable that represents the number of months. So if T is equal to 0 in this function, That means that the initial value is going to be 50. If t is equal to 8, तो ये क्या बनेगा? 2 raised to the power 8 over 8, and that becomes 50 into 2. T is the variable that is changing. जो k है, that's a constant. That constant is telling you कि कितनी देर बाद उस फैक्टर से इंक्रीज होएगा. T is a variable जिसकी वैल्यू चेंज होती जा रही है. As time passes, its initial value was 0, then it moves on to 1, 2, 3, 4, 5, 6. उसकी वैल्यू इंक्रीज होती जा रही है. So T is the variable. Okay? No problems? All right, let's move on. Okay, so this organization currently has 50 volunteers. If it's able to double the number of volunteers every 8 months, which of the following best models the number of volunteers it will have t years from now? Notice the difference of units. It doubles every 8 months, but then t represents number of years instead of number of months. How do we think about this? Remember that form? A, B raised to a power T over K. The units for T and K have to be the same. Now they have told us that T is supposed to be in years. So we need to convert K to years as well. Can we do that? What's K? 8 months. What's 8 months in years? 8 over 12, which is 2 over 3. That should be the value of K. Make sense? So what's the equation then? The initial value is 50. That's true in all of these cases. Factor भी 2 है सब के अंदर. The only difference is the power. So what power should it be? It should be 50 into 2 raised to the power T over 2 divided by 3. Let me actually write it more clearly. So it's T over 2 over 3. We can write this as 3T over 2. And that is C. Make sense? Okay? Alright, let's move on. One last example in this. The given function f models the temperature of a substance m minutes. Notice the units so that in case there's a difference later on, you can keep that in mind. Temperature of a substance m minutes. So one variable is time, m minutes. We're not representing that by t here. It models the temperature of the substance m minutes after it is exposed to this chemical or this gas, where m is between 0 to 10. Which of the following best models the temperature of the substance s seconds, okay, s seconds after its exposure to sulfur dioxide, where s is between 0 and 600? Now that looks quite weird. The equation is supposed to be in terms of S. S is in seconds. This is the function that we're given in minutes. How do we think about this? What do you understand from this, by the way? What's happening? 25.5 is the initial amount, right? That should remain the same, and that's the case in all of these options. That remains the same. What does this number tell you? 1.72. 1.72. What does this number tell you? It's the factor by which it is increasing. Every time the number is multiplied by 1.72, that's equivalent to a 72% increase, right? When is that increase happening? Every minute. Every minute, the value is increasing by 72%. All right? Now, what has changed? The unit is now supposed to be seconds, right? How do you convert this to seconds now? Does 1.72 change because of that? 72% to abhi bhi wahi rahega. It's still going to increase by 72%. So it's going to be the same as before. 25.5 into 1.72. This is the same. But then what about the power? Remember T over K. What's the unit? Seconds, right? T ki jagah pe we can use S here now. S over K. After how many seconds is the value increasing by 72%? 60 seconds. That is what we are going to have in the denominator here. S over 60. So that's what the function should be. That is option C here. Make sense? Any problems? You can confirm this like this as well. You know that 1 minute baad the value should have increased by 72%, right? That means after 60 seconds the value should have increased by 72%. ये तो आपको पता चल गया. This should be 1.72. You can confirm by inputting a value s equals 60 in these functions and see which one gives you a 72% increase. If you input s equal to 60 here, that will become 1.72 raised to power 3600. वो तो बहुत ज़्यादा increase हो जाएगी. That's not what we want. After 60 seconds, the increase should be by only 72%. When you input s equal to 60 in option C, that gives you 25.5 into 1.72 raised to power 60 over 60, and that becomes 1. So after 1 minute, the value increases by 72%, and that's correct. Is that okay? Yes. T in that form is the variable, right? K is a constant, जो उस particular scenario के ऊपर apply होता है. जितनी देर बाद increase हो रहा है, that's K. अब वो तो एक given situation में fixed होएगा ना. यहाँ पे for instance we know that the increase happens after every minute. So after 60 seconds, that's fixed. 60 is fixed here. So 60 is therefore a constant. Now if we want to find how much has the mass increased after 40 seconds, तो हम s की जगह पे 40 input कर देंगे. So s is a variable. कि हमें किस point पे value चाहिए? If you want to find the increase after 5 minutes, तो हम s की जगह पे 5 into 60, 300 input कर देंगे. Right? 60 is a constant in this function. That's not changing. ये clear है सबका? Okay. Now compare that with linear growth. Linear growth आपकी इस तरह से होती है, या तो you'll have a straight line with a positive gradient or a straight line with a negative gradient, right? In this case, we learned this before as well. M represents the rate of increase and B is the initial value, right? The y-intercept, that's the initial value. Now if M is negative, it's the value is going to be decreasing. If M is positive, the value is going to be increasing. Okay? I'm not sure if you call it linear decay or not, but linear growth looks like this. This you can say linear decrease, right? Or linear decay. I'm not sure if that is the correct terminology for linear or not, but you get the point, right? So what are the differences between exponential and linear growth? In exponential growth or decay, you are multiplying by a factor every single time, right? Whatever that factor is, you're multiplying by that to get the next value. In linear growth, you just add or subtract the same value every single time. Okay? In exponential functions, just make sure that the units that you have for t and k, they are both the same. If they're not consistent, you will not get correct results.